On this video, we solved the following quadratic equation by completing the square, and for those who also know the quadratic formula, we then solve it using that as well. All right, here's another problem on completing the square, where the coefficient is not 1. So how do we begin this? We would like the coefficient of x squared to be 1, so since the coefficient is 3, we need to divide both sides of the equation by 3. Whatever the coefficient of x squared is. So remember, that means you need to divide all terms on both sides of the equation by that coefficient. So this gives me x squared. Now 5 over 3, you have to simply write that as 5 over 3, 5/3 x. Now I could write plus 7/3, but what I'm going to do is put that on the other side of the equation by subtracting 7/3 from both sides. So I'll have a negative 7/3 on the right hand side. Now notice I put a plus on both of them. I'm going to do that to remember we're going to have to add something to both sides so that we can complete the square on the left side of the equation. Alright, now instead of doing this all in our head, I'd like to go down and say, well, what would go in this parentheses? This would be a perfect square of what? Well, to get the x squared, the first term will have to be an x minus sign here means there's a minus sign here, and you need half of the coefficient of x. All right, so if you can't do that in your head, how would you get half of the coefficient of x? You take half of 5/3, and nothing cancels, so that is 5/6. So 5/6 is half the coefficient of x. So when I square this, x minus 6 squared, I will get the x squared minus 5/3 x, and the last term will be whatever 5/6 squared is. So you square the numerator, square the denominator. That'll be 25/36. Whatever you add to the left side of the equation, you need to add to the right side of the equation. Okay, so the left side looks good. Now we need to get a common denominator over here on the right-hand side. Okay, I'm going to move this over just a little bit. Oops. Oh, it doesn't want to move over. Okay. So I'm going to get a common denominator. So I've got 3 in the denominator and 36. I need to get a denominator of 36. That's the least common denominator. So negative 7/3. Let's see. I'm going to multiply that by 12 over 12. And you can do this on scratch paper plus your 25/36. Hopefully you see now would have a common denominator of 36. So this gives me x minus 5/6 squared equals, all right, what does that give me? Well, I've got negative 7 times 12. So that's going to be negative 84 plus 25 all over 36. I'm just showing all the steps here. So we have x minus 5/6 squared equals, all right, we're still going to simplify. This will give me a negative number here. Let's see, I think that's what, negative 59 over 36. So I've got x minus 5/6 squared equals negative 59/36. So now we want to take the square root of both sides. Now remember, when you take the square root of both sides, you're going to have to put a plus or minus in front of this number over on the right. So on the left side, when I take the square root, I could just write the x minus 5/6. But on the right side, I have to put plus or minus in front of the fraction. So what will that be? Well, the numerator is the square root of 59. Remember what that means? That means the square root of 59. And the square root of the denominator will be 6. Well, the cool thing is at least I have the same denominator on both sides. Almost done. So this gives me 2 separate equations. But before splitting it up in 2 separate equations, I'm just going to add 5/6 to both sides. So I get x equals 5/6 plus or minus the square root of 59i over 6. All right, so this gives you 2 solutions. We have 5 plus the square root of 59I. Now make sure you don't put the I under the square root. Some people put the I in front of the square root, which is also fine, all over 6. And then we have 5 minus the square root of the square root of 59I all over 6. Now, since these are complex numbers, sometimes they're written in the form a plus bi, so you could also write that as 5, 6 plus square root of 59 over 6i and 5, 6 minus square root of 59 over 6i. Alright, so there we go. So our original problem was, let's see, here it is down here, 3x squared minus 5x plus 7 equals 0. And either way of these is a correct way of writing the solution. So we did that by completing the square. Now, for those of you who already know the quadratic formula, this is in other videos, let's see if we get the same answer if you use the quadratic formula. So if you use the quadratic formula, you take the coefficients of x squared, x, and the constant, if it's in this form, ax squared plus bx plus c. So here a is 3, b is negative 5, and c is 7. And I'm going to do b squared minus 4ac. I like to figure that out first, personally. So b squared will be a negative 5 squared, right? So negative 5 times negative 5 is 25. Minus 4 times ac. That means a times c. Well, 3 times 7 is 21. So that gives me 25 minus 84, which is negative 59. So remember, b squared minus 4ac is what goes underneath the square root in the quadratic formula. So the quadratic formula says the answer is the opposite of b. Okay, since b is negative 5, that'll just be 5. I don't think I'm going to have such quite a big line here. So that'll be positive 5 plus or minus. All right, now the square root of whatever I just found b squared minus 4ac to be. So it's going to be the square root of negative 59 all over 2a, and since a is 3, 2a is 6. And of course, we don't leave a negative underneath the square root, so that would be 5 plus or minus square root of 59i over 6, which could also be written as the way I have it right here. Okay, so we get the same answer if you know the formula for the quadratic formula. If you don't know it, then go on to my videos now on how to complete the square to get the quadratic formula, and then look at my videos on using the quadratic formula.